Hey everybody, Nathan Brown here with FCP Euro, and today I'm here to discuss the Volkswagen Atlas, specifically the engine, transmission, and driveline components. We'll be discussing some of the common maintenance issues, recommended service intervals, and some of the more in-depth problems you may experience with one of these vehicles. There's not a whole lot to get into on each one of these areas. We're going to start off with the engine, specifically the VR6, which is one of the more common options on the Atlas. So let's get to it. So before we get too in-depth as far as some of the common issues and repairs you might encounter, I'd want to go over the basic service intervals. Now, Volkswagen, like most modern manufacturers on any of these components, extends the service intervals far beyond what a lot of people would probably say is going to be your best recommended service for the longest life of the vehicle and the components in it. For any of these, when we're talking about the engines, we're going to start with the VR6 because that's what's in the vehicle behind me. We want to talk oil change and oil change intervals. So Volkswagen recommends a oil change every 10,000 miles or every 1 year. Now, based on my experience with these engines, with any of the modern engines, and just to the general way that these vehicles are used, usually want to shorten that up to about 5,000 miles or every 1 year. By staying up on your oil change intervals using a high quality approved oil for that engine, which we have available on fcpero.com, you're going to make sure that you're keeping your sludge to a minimum. All of the very crucial oil passageways and components that are fed by that oil are going to stay clean, they're going to stay operating the way that they need to, and you're going to generally have fewer problems over the long term. In terms of filtration, Volkswagen recommends an air filter every 40,000 miles or every 4 years. We would generally recommend checking it every 2 years and replacing it every 20,000 miles, but keep in mind that really depends on how you use the vehicle. So if you live in a place where it's really dusty, if you do happen to go off-roading or anything like that, you're going to want to check it a lot more frequently because obviously that filter is going to get a lot more dirt and debris in it, and you'll see better performance and better reliability by replacing it more regularly. They're pretty cheap, and it's kind of cheap insurance to stay up on that versus going to those extended intervals. And lastly, the most commonly replaced item in terms of regular service is going to be the engine spark plugs. Now, those are going to be replaced, according to Volkswagen, every 60,000 miles or every 6 years. And on the engine, on the VR6, if you're using it normally, i.e. you're not towing a whole lot or heavy hauling or anything like that, that's generally still a pretty decent interval. You could shorten it up a little bit if you do a lot of stop and go, if you're like sort of sitting at idle all the time, maybe shorten it by about 25% or so, but that interval generally checks out, and you'll generally see pretty good performance and reliability there. If your spark plugs do start to wear, you're going to see a loss of response, you're going to see a loss of miles per gallon, loss of efficiency and things like that, and that should come back when you do the spark plug replacement. Usually I'd also recommend doing the engine ignition coils at the same time, just to kind of refresh the system, make sure everything stays up. So with that, before I dive into what I have on the table here, let's take a look at the engine, and I'll kind of point out some of these components to you. Here on the VR6 on the Atlas, as you can see, it's kind of a unique engine arrangement due to the way the Atlas is built. And if you've checked out our buyer's guide or the suspension and brakes video that we did on this vehicle, you know that it's built on the Volkswagen MQB platform, which is actually a passenger car platform. Now, because of that, there's certain components that are reused across those systems, and it's why, despite the fact the Atlas is this really big SUV, the engine is way down low. So with the VR6, as you can see, most of the primary service stuff that you're talking about, the things that you're really going to touch the most often, such as replacing your spark plugs or ignition coils, everything is really accessible, super easy to get to, and for the most part there's plenty of room to do all the basic maintenance. Now, there's a couple things that we'll talk about related to the engine coolant and some of the more common leaks or possibilities for leakage or loss of coolant on these VR6 engines. And as you can see, the coolant reservoir is right here up top, super easy to get to, and very easy to visually identify just based on the level if you do have some kind of a coolant leak, such as at the water pump, which is going to be your primary area for that. Now, the water pump is located down on the lower front of the block here. It is a little bit tight to get to, so there's some stuff that's going to take a little bit more time than others. A lot of this stuff, this kind of plastic cladding, the air intake system, things like that, as they come off, you're going to have a little bit more access to the front of the engine. Now, On these VR6 engines, exclusive mainly to the 2018 to 2020 models, there were some variants that would occasionally develop a leak at the fuel injector, an external leak at the fuel injector. Now, those are located down underneath of this intake manifold here. So all that stuff does have to come off in order to access that. This is a direct injected V6, so with any direct injected engine from Volkswagen in America, you don't have any sort of port fuel injectors that are going to help clean the intake valves. So typically on a direct injected engine, as oil vapor and debris and things like that begin to flow through here and flow through from the crankcase through the PCV and get burned off in the engine, that can develop carbon buildup on the intake valves. Now, the VR6 has very, very large intake ports. It is not super sensitive to carbon buildup compared to some of the other models like the 2-liter turbos. So it's generally not going to be something that is a huge issue on these cars. The carbon's not going to be cleaned every 40,000 miles or something crazy like that, or even every 80,000. It'll probably go quite a ways longer than that. If, however, you do start to have an issue with carbon buildup on the intake valves, typically you're going to see a loss of power and response. You're going to see a reduction in efficiency or miles per gallon. And in very extreme cases, you may get cold start misfires. Now, the cold start misfires typically have to do with the amount of fuel and air that's necessary for these direct injected engines to warm up quickly. And basically that air fuel ratio gets thrown off and then you get that cold start misfire. Sometimes it'll be a soft misfire, you can feel it, but you won't get a check engine light. Sometimes you will get a check engine light. If you're having that issue, and if that's something that pops up and you're positive, you've done other checks, making sure everything else is good on the engine, that's a pretty clear indication that your intake valves probably need to be cleaned. Outside of that, as you can see, the air filter is super easy to get to. The valve cover right here underneath of the intake manifold, really not terrible to replace. As we'll talk about, this PCV valve here can occasionally go bad and need to be replaced. It's internal to the valve cover, so you have to replace the whole thing. But again, all of this is fairly straightforward, and you have a lot of room here. Probably if there is any disadvantage to it, it's the fact that it's a truck and you kind of have to be up and almost on top of it in some instances. One other thing I want to mention, and this is going to be pertinent to any of these Atlas vehicles, if you are working on the engine bay in any way, shape, or form, or in the electrical system, just touching anything that could be near a power source, disconnect the negative terminal in the battery. The reason for that, the ECU is located vertically directly next to the battery. It's some distance from the actual positive terminal, but it is merely a few inches from the fuse panel, the primary fuse panel and power distribution block. And all it will take is a split second of contact between one of those positive terminals and that ECU to have you essentially have an immobile vehicle with a fried ECU. Now, you don't want to have that happen because, one, you have to purchase the ECU to replace it, but then two, you'll have to tow it to Volkswagen in order for the immobilizer system to be properly coated. So a lot of times if you're working on a car, you may think, hey, no big deal, I don't need to really worry about that. I don't need to worry about disconnecting the negative terminal. If you're doing anything electrical or any kind of work anywhere near that ECU, always want to make sure you disconnect your negative terminal. So one of the areas that you may start to see a problem in the future on a 3.6 liter VR6 is going to be some kind of an oil leak at the oil cooler. Now, this is fairly common on the older variations of the VR6. The oil cooler on this generation is very different from those, but it still can suffer from those same failures. If you look here on the underneath of the vehicle, you can see there is a lot of oil residue that's built up, some down here around the bell housing. Using a light, you can look inside the bell housing there, and you can see that there's not any oil residue inside of that. So we know it's not a rear main seal or something like that. Kind of chasing the oil trail up, looking up as high as we can, try to see if it's the valve cover gasket or something like that. As you know, it's a little bit difficult to get to. It is not there. So we're seeing basically some residue where essentially one of the primary connection on the coolant pipe that runs from the water pump over to the thermostat housing has a lot of oil residue on it, and that kind of comes all the way down, and it pretty much cuts off right there where the oil cooler is. Now, essentially, the oil cooler is luckily pretty easy to get to. There are those 4 bolts there, and there's a gasket sandwiched in between. However, if you are doing this service, because coolant does run through that, you are going to need to do a full coolant service, drain and fill, and an oil change as well to make sure that everything is kind of flushed out and clean. So you definitely don't want to start undoing that before you get your coolant drained and taken care of. So probably the most common issue that you're going to run into on the VR6, or one of the more common ones, is going to be the need to replace the engine water pump. Now, these can occasionally fail at an earlier interval than what you would expect. If it is going to fail, it's probably going to start leaking or weeping at about 20 to 30,000 miles, and it's going to do so out of this little weep hole right here. Now, when that's happening, generally speaking, when you come to a stop or when the car is in the garage in your driveway, you might notice a very, very faint smell of coolant. Obviously, that's not a good thing, and you want to kind of investigate that. This generally, if it starts to fail, if the water pump starts to leak, it's going to be a slow leak. It's not going to instantly fail. You're not going to be stranded on the side of the road. But if you do leave it for an extended period, it will begin to wear out, and obviously that leak will get worse. So you want to stay up on it. As you can see, the water pump comes complete from Volkswagen with a new pulley all ready to go, which is really, really nice. So you don't really need any special tools to do this installation. And I usually recommend replacing the belt at the same time. Now, Volkswagen doesn't have a recommended service interval on this. If it's going to fail early, probably 20 or 30,000 miles, I generally recommend preventative maintenance, replacing it at every 60 or 80,000 miles or so. Depending on the car, the components and things like that, I'd usually also recommend replacing the engine thermostat at the same time, but that generally isn't going to fail in the same manner as this with a major coolant leak or anything like that. You always want to make sure you use the recommended coolant for that vehicle. There's a few different variations of G12, G13, G12 Evo, etc. From Volkswagen. So you want to make sure you're using the appropriate coolant, just like you want to make sure you're using the appropriate engine oil for your year, make, and model of Atlas. So as you can see, the fuel injectors for the VR6 are a very, very unique design. You have these 3 short units and then 3 long ones. And the reason for that is because of the unique design of the VR6. It is a V6 engine, but it's a very, very narrow angle. It's only 10.6 degrees on the V. So whereas you're thinking of maybe an American V6 or something more traditional that's going to be at 90 degrees or so, it's a very narrow engine. The fuel injector leak issue is really kind of exclusive to the 2018 to the 2020 models. When they did start to leak, it would actually be usually at the end of the injector, like the visible portion of the injector. Typically, when you think of a fuel injector leak, it actually leaks fuel into the cylinder and develops a running issue like a misfire or can flood the engine. But on these, it would actually be an external leak. Now, obviously, if you stop the vehicle and you turn it off and you begin to smell a little bit of a fuel smell or something like that, that's a huge red flag. You want to do an inspection, you want to check it out much more closely, and if you do see any kind of a fuel leak or you're experiencing any kind of a strong fuel smell, you definitely do not want to drive the vehicle if you have a fuel injector leak. Again, it's typically going to be toward the end of the injector, and it should be something you'll be able to see or smell quite easily if it develops that problem. Now, on the newer VR6 engines, it's not really much of an issue. It's not something that is common, but it is something to be aware of just in case. So one of the other more common problems on the 3.6 liter direct injected VR6 that you find in the Atlas is to have an issue with the PCV valve. Now, the PCV valve is also called an air oil separator, and it's a crucial component of your positive crankcase ventilation system. Essentially, it's an emissions component, and this unit, which is stored inside of the valve cover right here, essentially regulates pressure and oil vapors between the engine crankcase and the intake system. The whole idea is that it captures the oil vapors, it allows those to be fed back into the intake and burned off safely versus being vented to the atmosphere or something else that would generally not be emissions compliant. Inside of this unit right here, on the back side, actually nestled in here, you can kind of see where it lives, and you can see a little orange tab here. This is where the actual diaphragm for the PCV valve lives. And as you can see, it'd be somewhat difficult to replace. And usually the only way to actually take care of it is to replace the entire valve cover. Now, traditionally, this was only available genuine, but thanks to L-Ring, you can actually get this complete unit fully dressed with hardware and all the gaskets you need for significantly less money than the genuine unit. So if the PCV valve does begin to fail, most often you're going to notice a few possible symptoms. So first off, you may notice an increase in oil consumption. You may hear an audible squealing noise, which is essentially the air rushing through a tear in that diaphragm. Or you may start to see, in an extreme case, some engine misfires, usually at idle. Outside of that, those are the primary things. If you were to continue to drive the vehicle with a bad PCV valve, you can potentially develop other problems down the road, but it is less common on a VR6 than some of the other models, like the 2 liter that we're going to get into later. The only really other byproduct would be a leak in the rear main seal. Now, that typically is going to occur because of the increase in engine crankcase pressure that's allowed to sort of exist there, and that pressure essentially pushes on that rear main seal and can develop a leak. Again, less common on the VR6 than the 2-liter, but it is a possibility. The only other real thing to consider, and it's not a big deal on the VR6 because it's easy to get to and it's a pretty short unit, but usually by the time the PCV valve begins to fail, you want to check your other related components, such as this breather connector here, because that plastic will degrade and break down and get brittle over time. So when you're going to replace your valve cover, you don't want to go to take this off and have it snap, and then you're down while you order another one. So typically you want to get both of these at the same time, do the job, call it good. There's not really a mileage interval on this one. It can depend on a lot of variables, but it's usually going to be over 100,000 miles that this is going to fail. If it does fail under that, it's probably going to be fairly close to that. So again, not super common, but it is something to watch out for, and it will eventually fail on pretty much all of these vehicles. So the last thing that I'm going to talk about specific to the 3.6 liter VR6 and the Atlas has to do with the timing chain system. Now, I have the basic components of the system laid out here. As you can see, we have two chains, the upper timing chain and the lower timing oil pump drive chain. We have our tensioners and guides and everything else. Now, all of this is, of course, lubricated by the engine oil, and this is why you want to stay up on your oil changes and, in fact, reduce the frequency from 10,000 miles, as I said, which is what Volkswagen says, to 5,000 miles. Now, a lot of time on a naturally aspirated engine, something that runs, a little bit lower stress, you might think you might be able to extend that, but the VR6 engine does generally run fairly high oil temperatures. So you want to stay up on your oil changes to make sure these components stay fresh. Now, there's essentially 2 or 3 things that can happen with this, and it's usually going to be on cars that either have not been properly maintained or are very, very high mileage. First and foremost, you have these guides, which are obviously all made out of plastic. Now, the chains are running on these guides, and they're significantly better designs than many of the older cars out there. It's a pretty robust piece, and the chains you can see are quite beefy. But as the chains begin to wear on this plastic, you will start to develop a little bit of extra play in the system, and eventually, over very, very extended periods, these can even break down and possibly break. Now again, that's pretty rare on these cars. It's not unusual to see well over 200,000 miles on one of these engines with original timing chains. That's to say they don't all last that long, but again, it depends on how you use the car. One of the other reasons, other than the physical wear on these actual guides, that you want to be careful and you want to stay up on your oil changes has to do with the tensioners. So I have this tensioner here, which is the actual upper timing chain tensioner that pushes on the back of this guide right here, and it is oil fed. So you have little passageways inside of here that help to keep this piston tight and keep the appropriate amount of tension on that chain. If you don't do your oil changes, if they begin to gunk up and there's a lot of sludge or debris inside of there, that can affect how that functions. Now, one nice thing about this is this tensioner is externally threaded, so you can actually change this without having to take everything apart, but it's not a super common failure issue. Usually it will last as long as everything else in the system, and when it's time to replace things, then you'll need to replace it. On the lower half here, we have another chain tensioner. This is for the oil pump drive and a singular guide. Now, as I pointed out on the vehicle behind me, this is actually sandwiched between the transmission and the engine itself, so it's sort of in the middle. It is a bit of a job to replace. So if you do have to service these components, you generally want to do everything all at once while you have it all apart, just to basically save on labor and save the hassle from having to do anything else again for another 100, 150, 200,000 miles or something like that. So how do you know when you need to replace or service your timing chains? There's a couple different ways. One of the more common telltale signs is going to be chain noise at cold start. Typically that's because the tensioner may have developed a little bit of a loss of oil pressure, so it is no longer keeping the appropriate amount of tension on the chain for cold start. Once you start the vehicle and the pressure comes up, then the tensioner tightens up, and then you don't hear that chain noise anymore. So it's usually only going to be for a couple of seconds. Now, it's worth noting that that chain noise is essentially the chains slapping around inside the engine. That's one of the ways that these guides can actually have accelerated wear, is from the chain physically slapping around versus the consistent wear. The other and the actual accurate way to measure if your timing chain system needs to be serviced is to measure the degrees of correction with a diagnostic tool. We use and recommend VCDS, which is the VAGCOM diagnostic tool. It's manufactured by Rostec. We do sell it on the website. It is absolutely invaluable if you have a modern Volkswagen or Audi vehicle, and there's multiple versions available at different cost levels depending on how many cars you service, how often you plan on using it, and whatnot. So what you want to do is go into the engine measuring blocks and check the correction on the timing system. Basically, that's going to be somewhere probably in the 1 degree range, hopefully something very, very low like that. As the chains stretch or as the system wears, it's going to go up. Once it gets to that 4 degree range, that is a surefire sign that the timing chain system does need to be serviced on that vehicle. So there's one other thing I want to touch on, and it's generally pretty rare, and it's exclusive to the very, very early production 2018 and possibly some 2019 models. And that is, on the VR6, some of the engines from the factory actually had incorrectly torqued head studs. Now what that means basically is that the head on the engine does not have the appropriate torque, and the head gasket would then begin to leak. It would typically leak on the front side cylinders, which are 2, 4, and 6. So if it were to occur, it would happen at very low mileage, 20, 30,000 miles. And if it were going to be a problem, it either would have been addressed or repaired in some way, or it was not a problem on the vehicle that you're looking at. So you want to be aware of it, especially if it's, for some reason, you're looking at a very low mileage unit. But generally speaking, the repair would have been done at some point in time. If you are concerned about this, typically what's going to happen if the head gasket is leaking is you'll begin to notice a loss of coolant with no obvious coolant smell or any obvious leaks, such as, at the water pump or something like that. If that begins to occur, and especially if it begins to accelerate, what you want to do is use a borescope and inspect the actual cylinders to check for coolant being present and being burned off. Cylinders 2, 4, and 6, which is the front side of the engine, are the ones that are typically going to be worse, and there will be a very, very clean, shiny piston in there without any sort of carbon buildup or anything like that, because they're literally being steam cleaned by that coolant. If it has gone on for a very long time, or if it is extensive, there might be a very, very sort of a pink tinge to them as well, since all the coolant used by these cars is pink. But again, that's going to be fairly rare, something to be aware of, something to look out for. But for most of the cars out there at this point, that's not really going to be too much of a concern for a purchaser. So now that we've gone over the VR6 variant, we're going to discuss the 2-liter turbocharged engine, which is the other variation available in the Atlas and Atlas Cross Sport. Now there are actually 2 different 2-liter turbocharged engines. There's the EA888 Gen 3 and then the EA888 Evo engine, as they're called. So we're going to discuss the more common variant first. That's going to be the Gen 3 TSI, and then we'll get into the Evo as well. There's some similarities between the two, but there's a couple very small changes to discuss. We have a couple other video guides on the Gen 3 TSI engine that already exist, and a lot of this is going to be very similar to the other stuff that we've gone over in the past. That engine is used across a bunch of different Volkswagen vehicles, and a lot of the same things that we're going to talk about today will also apply to those. That said, there are a lot of specific things to the Atlas in some of these parts and pieces. So an intake manifold from a GTI is not necessarily going to work on an Atlas if you have a 2-liter Atlas. So before I get into the specifics of what I have on the table, and I know it kind of looks like a lot, I do want to touch on the service intervals for the 2-liter turbocharged Atlas variations. So just like on the VR6, Volkswagen recommends a 10,000 mile or a 1-year service interval. Just like on the VR6, I would recommend having that service interval in terms of mileage, so a 5,000 mile oil change or every 1 year. Just like on the VR6, you want to make sure you're using the appropriate oil specification for your year and model of Atlas. And I'll get a little bit further in depth in that just a little on in the video, because there's actually multiple variations of oil spec for these vehicles depending on what year you have. On the Gen 3 TSI, it is a little bit more complicated since it is a turbocharged engine, and it's a little bit more of a modern design than the VR6. So some of the components are a little bit smaller, a little bit more delicate. But probably the most common thing that you're going to encounter on a Gen 3 TSI Atlas is going to be a leak at the water pump. This unit right here is a complete water pump and thermostat housing assembly. It's driven by this belt here and is all in one unit. You can see right here, it actually connects to the block through these passageways, and this is generally going to be where you're going to get a leak at the water pump. It is said that some of the modern Volkswagens, the smell of leaking coolant is just the way that they smell in general. It is very common to get some whiffs of coolant, some coolant smell from the area where this water pump sits on a 2-liter engine, which is going to be down below the intake manifold on the passenger side or the timing chain side of the engine. However, if you're not seeing any reduction in coolant levels, if you're not seeing any obvious signs of coolant leaks, that's not necessarily an indication that it's leaking already. In terms of mileage or service intervals, it really can depend. You'll see a lot of variation here, but generally what will happen is because you have heat, vibration, different levels of thermal expansion between the plastic and the cast iron, which is the block, that's where you're going to generally start to get your leaks, is between this housing and the block. So the other, probably most common or more common sort of failure point on a Gen 3 TSI is going to be with the PCV valve. This is a pretty common component for replacement. It's thankfully fairly easy to replace. It just sits right on top of the engine. And this is the PC valve, or positive crankcase ventilation valve, or air oil separator. As with any other modern engine, the PCV valve, or the air oil separator's job, is to try to keep the oil vapors that need to escape from the crankcase, keep those intact, feed them back into the intake, and make sure they get burned off safely within the engine versus getting out into the atmosphere. So just like any other PCV valve, there is a spring and a check valve essentially, and then a rubber diaphragm that kind of keeps everything happy. And as the heat and as the oil vapors and sort of as it is used, you're going to eventually develop a tear within the diaphragm on that valve. Just like on the VR6, you're going to have a few different possible symptoms if you have a bad PCV valve. Typically, you will see an increase in oil consumption. It is more common to see misfires at idle on a 2-liter that has a bad PCV versus the VR6. And eventually, you can have some issues with some other components, like I mentioned on the VR6. So on the 2-liter, the rear main seal design is a much more delicate design than on the VR6. So it's a lot more susceptible to an increase or excessive positive crankcase pressure. So if your PCV is bad, if you're having that whistling noise, if you're having consumption issues, anything like that, you want to make sure you get that replaced quickly, because you do not want to have to replace this rear main seal where the transmission needs to come off in order to replace it. So if you were to have a bad PCV valve, it is possible to get a check engine light. You won't always necessarily get one right away. If you do, it's probably going to be related to like a leak in the air intake, or a leak in air intake system, something along those lines, because essentially there's unmetered air going back and forth and throwing off some of the sensors. Now you can see I have 2 different hoses here. So there's 2 different variations. There are some production splits on the 2-liter Atlas for the PCV system. So you want to make sure you're choosing the correct one based on the build date of the vehicle. And whenever you're replacing the PCV valve, you'll probably want to go ahead and replace the breather hose as well, because again, those start to get pretty delicate and brittle. It is likely that when you go to remove it, it might fail, crack, or give you some additional problems. So the next component that I'm going to talk about for the Gen 3 2-liter turbocharged Atlas is going to be the intake manifold. So the intake manifold setup on the TSI engines in general had been troublesome in the past, and they're much better now than they were back then. However, it is still possible to get a fault with the intake manifold. So there is an intake runner flap inside this manifold that will change position depending upon the engine RPM, depending upon the boost pressure, but mainly depending upon the temperature. So this is one of the most crucial components of cold start on the 2-liter turbocharged direct injected Gen 3 TSI. And what will happen is you'll just get a physical fault within the motor of that flap. It's not usually that the flap actually fails or gets stuck or anything like that, although it's certainly possible. Typically, it's going to be an electronic fault within that component. So because of the way these are built, they are not serviceable at all. You can't replace just the electronic components, so you do need to purchase and replace the entire intake manifold. Now, as you can see, it comes complete with all the gaskets and everything you need, and unlike some of the other earlier engines, you don't need to touch the fuel rail or fuel injectors for replacing this intake manifold, so it is a little bit easier. If it does have that fault, the car will still generally run fine, but obviously you're not going to pass emissions if they scan codes for where you live and the area that you live in, and you will want to get that replaced and updated. So while we're talking about the intake manifold and the intake system of the 2-liter turbocharged engine, being direct injected on a turbocharged engine, you are going to have some problems with carbon buildup on the intake valves of this engine. It will need to be cleaned periodically. The mileage on that's going to depend quite a bit on how you use the car, how you drive it. As a general rule, somewhere around 80,000 miles or so could be when it'll need to be done. Some engines that maybe if you have a heavier foot, you spend a lot of time on the highway, you don't do a lot of stop and go or sit in traffic or leave the car idling for long periods, you might be able to push that to 100,000 or a little over. If you do a lot of local driving, very short trips, you idle the car in parking lots all the time, things like that, it'll probably shorten up quite a bit. So it's not unusual to see it at 40 or 50,000 miles if you never get the thing over 2,000 RPMs and it's just kind of loafing along. If you do have a 2-liter turbocharged Atlas, it's important to get your foot into it a little bit, generate some heat to help burn off and keep some of that carbon off the intake valves. So if you do have carbon buildup on your intake valves, it will definitely start to have a degradation in horsepower and response. You'll start to see a reduction in miles per gallon, and eventually you will have cold start misfires. Cold start misfires you're probably not going to notice until it's maybe 40 degrees out. If you live in a warmer climate, it may not be as much of an issue, but once it gets cold, especially closer to freezing, you will start to see those cold start misfires. Check engine light will flash. If that's a surefire sign that you need to have your intake valves cleaned sooner rather than later. So that's definitely something you can do yourself. It does take a little bit of time and some additional tools, but it's certainly something you can handle at home with a few hours in the garage. So the next few things I'm going to talk about are going to either be less common or they're going to be things that will only generally happen on much higher mileage vehicles or perhaps in certain instances on vehicles that aren't properly serviced. So I talked about the importance of a shorter 5,000 mile oil change interval and using the correct specification of oil. And the reason for that is you want to make sure that the timing chain system, which is this piece right here, timing chain tensioner, and other oil-fed components like the turbocharger are properly lubricated and protected while you're driving the car. On the timing chain system, you have this tensioner here, which is oil fed. It does have a check in it to help keep tension on it when the oil pressure maybe does bleed off. But all of the oil passageways within this and the cam adjusters and everything else are very sensitive, and you want to make sure that those are clean. These rails right here are fairly delicate for what they are. So again, as the engine is run, if the oil is dirty, if it's the wrong kind of oil, you may start to see some accelerated wear and some issues here. So similar to the VR6, you can check and see with a VCDS, a VAGCOM system, exactly how much timing correction is being put into the engine from the computer. So essentially, if it's fairly low, 1 degree, something like that, you're A-OK. As you start to creep up to around 4 degrees in either direction, either timing retard or advance of correction, that's going to be a sign that this chain has stretched or there's a component in here that is out of adjustment essentially and it can no longer tension the chain appropriately. If you do get to that point, you definitely want to have it serviced pretty quickly. It is possible for the timing chain system to jump time on these engines if it does get really, really bad or a component breaks completely. But as opposed to the VR6, this system is fairly accessible and relatively easy to get to for these primary timing components. There are some other parts of the system that are not on display here, so I'm really just talking about the timing that goes from the bottom half of the engine up to the camshafts, keeping the valves and the pistons and everything happy and good to go. So one of the other major components of these engines that really doesn't fail incredibly often, but it will start to fail as the mileage starts to go up on these vehicles, or again, if they're not properly serviced when it comes to oil change intervals and things like that, could be the turbocharger. So this is oil lubricated and it is also cooled down by the engine coolant. So as a rule, these turbochargers are pretty reliable at the end of the day. However, it is possible for there to be play that will start to develop within the turbocharger impeller, within the compressor and the impeller wheel, and you'll start to see some issues with regards to either codes or underboost performance, things like that, where the turbocharger is no longer able to create the boost pressure that the ECU is looking for in order to perform and make the horsepower that it needs to do. Within this unit, you kind of get it complete like this. This is an IHI turbocharger, which is the OE manufacturer for Volkswagen, so you can get this one a lot cheaper than a genuine unit. And this is very similar to the same turbocharger that's used on any number of other Gen 3 TSI engines out there. So it's just a simple 4-bolt connection, V-band to the downpipe, and you're good to go. So I wouldn't expect to have to replace this all that often until the cars start to get much higher on mileage, but it is something to be aware of that on a turbocharged engine, this is eventually sort of like a wear item that you may need to replace. So the last two things I want to touch on are fairly rare, or they're certainly not going to be as common. But the first is going to be a leak at the cam girdle or the cam plate. Now, the Gen 3 TSI engine does not have a traditional valve cover where all the camshafts and everything are underneath of a plastic or a metal cover, and that goes over top and there's a gasket. The cam plate is essentially integral to the design of the engine and is visible basically from the outside. So there's no gasket there like a traditional rubber gasket, it's this chemical gasket. These are two of the options that we have on our website. This sealant right here is an anaerobic sealant, and it's quite tough. And that goes, again, between the cam plate and the head, and the camshafts are riding inside. Over time, extensive time, because of heat, because of oil contamination, all those other things, all the extremes that the engine goes through, you can eventually see a breakdown in this sealant, and you will start to get some seepage on the cam plate, some oil seepage around that cam plate. The only way to reseal it is to remove the cam plate, clean all the old sealant off of it, and then apply new anaerobic sealant from Volkswagen. Now, we have the genuine stuff here, which is very, very expensive, and it is green in color. And then we have this aftermarket version from L-Ring, which is red in color, but it does exactly the same thing. And the reason why you want to use an anaerobic sealant versus like a silicone or something that's a little bit more traditional that you might think of, is that this, when it gets inside of the engine, is not going to clog any oil passageways, it's not going to clog any pickup tubes or anything like that. It's essentially designed that some of it will probably get into the oil of the engine while it's being assembled, but it'll be able to pass through cleanly without issues, and you're not going to have any problems. So you always want to make sure that if you are doing that service or having that service performed, that they're using the appropriate type of sealant on that cam plate. Last but not least, on the table here, this is the upper timing chain cover. Now, this would normally be replaced while you're doing a timing chain service. The reason that I have it on here is that, as you can see, it's made out of plastic. Now, this unit does come complete with all the hardware and gaskets and everything, which is great, but the oil fill cap is right here, and being made out of plastic, as they start to age, and depending upon who's doing your oil services, if they're maybe a little ham-fisted and aggressive or rough with the cap, it is possible that these can crack. It's not very common, but it can happen. And if it does crack, your oil cap's not going to seal appropriately, and then this will need to be replaced. Not the end of the world. It's pretty easy to get to, and it's fairly inexpensive, but it is something to be aware of if you take your vehicle to a standard lube shop where maybe they're not quite as delicate as they may need to be with some of these components. So outside of either repairs and maintenance they may be expecting, or something that maybe came up because of a lack of maintenance or some other type of failure, really the only other thing that you're going to have to replace with any regularity on a 2-liter turbocharged Atlas or Atlas Cross Sport is going to be just a simple ignition service. The ignition coils and spark plugs are scheduled to be replaced every 40,000 miles or every 4 years, according to Volkswagen, and that interval is correct for 99% of the usage out there. You want to make sure you use the appropriate specification of spark plug, and generally, again, I'd recommend replacing your ignition coils while you're in there to do that, but that's pretty much it. So in 2024, Volkswagen stopped selling the VR6 variant of the Atlas and Atlas Cross Sport, and the only version is a 2-liter turbocharged version. So that's what they call the Gen 4 or the Evo TSI engine. It is very, very similar to the Gen 3, but there's a bunch of additional or new updates that are specific to it. So first and foremost, it makes more horsepower, it makes more torque, but it does rely on a lot of the same similar components as the Gen 3. So if you have a 2024 or newer Atlas that uses that particular Gen 4 Evo, water pump issues, still going to be the same thing. It uses the exact same water pump and mounts in the exact same ways, so you can still have all those same leakages. Timing chain system, again, very, very similar. You can have the same potential issues as far as timing chain stretch and things like that. It's not likely at any kind of a low mileage, especially with the cars being fairly new at the moment, but it can still happen. PCV system, same basic design. There are a bunch of updates. There are a lot of changes to the Gen 4 variation, so it is said to be a little bit better. But because you're talking about oil, vapor, heat, you're talking about a rubber diaphragm inside of that unit, it will eventually develop a tear or a leak, and it will eventually need to be replaced. Again, that's going to be later on down the line, but that is something to watch out for. On the Gen 4 Evo engine, one of the biggest changes is going to be with the turbocharger. So this is an IHI turbocharger. The Gen 4 uses a Continental turbocharger. It's one of the ways that it can make more power than the Gen 3. And those Continental turbos are generally a little bit more robust, considered to be a little bit more reliable than the IHIs. So outside of that, if you have a 2024 and up, there's not a lot that's really popped up yet in terms of major service concerns. It's really just the components that we know are crossed over or borrowed from the Gen 3 that eventually you may have to watch out for. But there's certainly some things to keep in mind. Now, the last thing I want to talk about, we're going to talk about oil, and specifically the different kinds of oil and specifications and weights that you may need for your Atlas or Atlas Cross Sport. So we'll reset the table, get all our oil up here, and start talking about that. So I've said multiple times in the video to always make sure you're using the appropriate specification of oil for the engine that's in your Atlas, but I haven't really gotten into the weights or the actual specifications. And the reason for that is that there are multiple versions or variants depending upon the year of your Atlas and what engine you have in your Atlas. So without going too in depth, I'll go over essentially what you're going to likely find under the hood of your Atlas depending upon when it was made. So first, the way that Volkswagen specifies their oils is going to be by the Volkswagen specification number or type, which is going to be typically VW 50200 or 50500, etc. And it's going to be a 3-digit number. It's probably going to start with a 5 and end with some other digit. So the 502 is going to be the older specification oil, and that's going to be more common on the older Atlas models. This is typically going to be a 5W40, 5W30, or possibly a 0W40. We typically recommend the 5W40 in most use cases. If you happen to live in a very cold climate, you could move to a lighter oil like a 030 or a 530. Typically 540 will protect the engine properly and do everything it needs to do. Some of these slightly newer Atlases, something that's going to be somewhere closer to 2020, 2021, it is likely that it may specify a 502 or a 504, or it may just specify a 504. Now, 504 oils are typically going to be a 0W30 or a 5W30. This one right here is a 504 spec oil, but it's 5W30. This Atlas behind me is a 504 0W30. You can still use this in that engine because it still meets specifications, but it is important to denote that you are going to find that variance from time to time. This 504 spec oil is also going to be used on a lot of the 2-liter engines all the way up until 2024. In 2024, they went to the 508 specification, which is a 0W20. Now, you may think to yourself that this is entirely too light, it's not going to protect appropriately, but generally, these newer engines are all designed for use with a much lighter oil, and thanks to the additive packages and the other kind of ingredients that make up a modern engine oil that extend the life and do everything that it needs to do to protect an engine under modern conditions, you can rest assured that as long as you're choosing the correct oil specification for the engine in your Atlas, you will be getting the appropriate amount of protection. So the 0W20 is going to be used on all the 2024 and up, and most newer Volkswagen engines moving forward from there. We have these and a number of other oils available on FCPeuro.com. These are typically going to be kitted together so you can have a complete engine oil change kit that you can easily purchase and do oil changes at home with no hassles and no questions about whether or not you are getting the right oil for your car. So hopefully today you've learned a little bit more about the engines available in the Atlas and the Atlas Cross Sport, some of the common maintenance recommendations and some of the common problems and maybe more uncommon problems you might encounter in the life and service of these vehicles. If you have any questions, if you have any ideas or any thoughts, something that we didn't touch on or something that you'd like us to talk about, be sure to drop a comment in the section below. We also have a number of DIYs available for both of these engines, covering a lot of these more common maintenance issues. If there's one that you're looking for that you don't happen to see, again, let us know in the comments below. So if you did enjoy the video, please let us know, like, subscribe to the channel, and we will see you on the next one.